He is a JavaScript wizard. Coming up to, he's created PostCSS, which has hundreds of plugins and add-ons created by other third-party developers. He also created Autoprefixer and Logux. He's a nomadic worker. He's been in over 50 countries so far. He's currently in New York, and but he works remotely, kind of travels around. He's going to talk to you today about moving beyond GraphQL, and there's a topic up there on screen. This is Andrey, thanks. Just a minute or two.
Thank you. So yeah, hello everyone. My name is Andrey Sitnik. I'm working in Evil Martians company. Every time when I cross the border, they ask me, is it a real name or you just fake it? And I created Autoprefixer, PostCSS, and browser list. Initially, Autoprefixer was created in 2013. Unfortunately, announced was only in Russian, sorry. And by some reason, the whole system became very popular. Not because it was a great project. To be honest, I was just lucky. There were a lot of different projects which was much better than PostCSS, but likely hype train chose me. This is why the project became very big. And unfortunately, as any project, this project became too big, and it doesn't need me anymore. We have all features that people need, and it's hard to add something new. This is why I start to think a little, to be a little sad, because I'm not the person who wants to travel, to have time, to be free in the night. I really want to be burned out by open source every night. This is why I started to find some new adventure, some new crazy project. And so the main question was, what will be the next big thing? And of course, first and obvious choice is GraphQL. GraphQL is really amazing idea. If you don't use it right now, you definitely should at least consider it. But for my case, there is only one problem with GraphQL. It's already mostly solved problem. Of course, they created APIs, they created code. They need only to polish it and promote. And to be honest, it is very hard work. I really appreciate people who do it. But I want some different idea, maybe when we don't know answers, or even more, when we don't know questions. This is why I started to think. What will be after GraphQL? What will be the next thing in synchronization between client and server? And I found answer on the talk of Viktor Grishenko, mad Russian scientist. He presented CRDT, his Swarm.js. It's a JavaScript implementation of CRDT, maybe the best one. And I was convinced so much that right now I believe that CRDT will be the next big thing. And I will try to convince you as well. And to do it, to convince you, I will use these 3 steps. So I think that a lot of technical revolution, multiple revolution, happens by 3 steps. First step is some unusual problem. Second step is when to solve this unusual problem, we are finding some old forgotten theory, because we are living in postmodern era, and most of idea was already created. So unfortunately, this is the only way how we can find new ideas, only in the history. And third thing, after solving this small, non-standard problem, we found that it could be implemented in any different ways. For instance, Open America, it was, they tried to find India and use all forgotten theory about around Earth and went to the different direction. But my favorite example is React. Initially, they started a project to solve this problem with notification. And they found idea of functional programming. But then they found that it is really great framework for general purpose. This is why right now most of developers are not JavaScript developers and just React developer. And right now, all React developers can think that they are functional programmist. So at least it's a good thing. And functional programming was very old theory. It was from 60s. Same with Redux. Initially, Dan Abramov was maintainer of React Hot Loader, and he had a talk about how to write programs in the best way to work with React Hot Reloader. And to make this talk, he found Elm framework. It's a very interesting framework, but unfortunately, it's not so popular. A lot of people think that it is created by mad scientists. It's not for the regular people. But they have a lot of interesting idea. And Dan Abramov took all this idea. Now you have Redux, very interesting way. Same 3 steps. So to describe why CRDT is so great, I need some small but very non-standard problem. So let's make a to-do application. Very unstandard problem. So we will have a list of the tasks, checkbox, likes, and a big description area. Of course, to be honest, it's the most standard problem. We all was prepared for this task. We all can do to-do manager, even without writing code, mostly copy-pasting from the guides. And we can do this, some stuff. Like, we can take Redux, use actions, similar Redux stuff. How many people here use Redux, by the way? Yeah, I think you know it. Or we can use Vuex or any other framework. Because this is application, we need somehow to communicate with the server. This is why we will have a JAK requests. When user, I don't know, do something, we create new task. We will dispatch action to show the loader, and then we will start a JAK request. And in the end, we will show that everything is done. And if we are a very good developer, we will care about errors. Unfortunately, most developers don't care about it. Or we can do the same with GraphQL, no problem. Yeah, it's pretty obvious code, there is nothing here. So we done the project, we deliver it, we're waiting for the money, but then client told us that he forgot one small extra feature, that multiple clients, multiple users should work on the same tasks list in the same moment. So it should be collaborative. Like, is it easy to add? OK, what we can do? First, the main problem, if multiple users work on the same data, we will have edit conflicts. When 2 users change the same task, we need somehow to merge these changes. Of course, we can ask a user to merge it. Like, it was a first idea that could be found in your brains. But it's very wrong way. It doesn't work like this. Unfortunately, we really need automatic conflict resolution because, first, users will not do it. They really don't hate this type of interface. But also because machines must suffer. People should not do any work which could be done by machines. So this is why we should take care about some sort of automatic conflict resolution. Of course, we can do some hacks around GraphQL, but unfortunately, it will be not good solution. Instead, we can go to a different direction. We can go to the dungeons of computer science and to try to find some interesting new old ideas. And this journey will be long and interesting, but to be honest, it will be very fast. In dungeons of computer science, we will find a distributed system. The idea was created in the 80s, and this is a pretty interesting idea. So, distributed system. When I'm making an application right now, I have JavaScript application, server, and they are separated. They are 2 separated applications. And mostly, when I do some AJAX request, I don't care about how server will deal with it. I just send it. And most of users just don't care about the errors during the network requests. Distributed system is a very different approach. This approach, we have multiple components in our system on different machines, and they are part of one system. And we don't send requests. We synchronize the state. So let's go to see some real stuff. what if we have Redux and two users change the same task? Then these two users send this task to the server. If we will send a whole our state to our servers, we will have a problem of conflict resolution. Right now, what server should get from each user? And if we have problems with algorithms, like it's very hard to write all these conflict resolution algorithms. If you have problem with algorithms, you should change data structure. This is a very interesting idea. So let's change how we communicate with the server. Let's send not a state. Let's send what was actually changed. Let's send changes to the server. In this case, one client will send likes, and other clients will send a new name. And as a result, we don't need to merge it. It's not a conflict anymore because we can just put these two operations in the list of operations, that's all. This idea called event sourcing, it's a very old idea. I even can find who was initially author of it. But what we should put, like we need to send what was actually changed, but what is it in real? In real, it's this Redux action. Redux action has the same idea, what was actually changed in your application. So this is very important part. Let's take our to-do application and remove all AJAX requests. Let's remove all mutations and sagas. Let's remove loaders and do completely different thing. Our to-do application will keep WebSocket connection to the server. And every time when the user changes something, of course, we generate a Redux action, like in any Redux application. But instead of showing loader, we will apply these changes immediately to our interface and send the same action to the server by WebSocket. In this case, we don't need loaders anymore because we can use, because our interface will be instant. We synchronize in the background. We change it immediately, and then in the background, we synchronize the changes. Server, when it will receive our action, save it to database, but also because it keep connection with all other clients, the server can't resend the same action to any other client. So we have light updates out of the box just by design. And we can do even more interesting stuff. Because we keep WebSocket, server could generate action at any moment. And this action, Redux action, will be sent by WebSocket and applied in our clients. It's really open. It's open a lot of possibilities for you as developers. Okay, this is optimistic UI. But what if we want to make a pessimistic UI? For instance, the payment. Payment should always show the loader, unfortunately. There is no way how we can do it without loader. In this case, it's not a problem. We will just use two different actions. One action to ask server to change something, and second action, which was created by the server, that server did this action, what we asked. In this case, we use ask for payment and pay it. And the first action will be reduced to a loader, and second will be reduced to everything is paid. Okay, but I know you're really worried about that I'm covering only very simple cases. But what if it is a real production case when we have all problems? What if there is no connection? What we will do in this case? To be honest, it's not a problem. First, if there is no connection, there is no WebSocket, we will show some warning to the user that there is no connection. And second, our Redux already can save our action in the memory. You already do it when you use Redux DevTools. So if we don't have a connection, we will keep this action in our memory. We already can do it in the Redux. And when we will have a connection, we will send a whole bunch to the server. Okay, it's a simple question. What about more harder problem? What if you have a database error, or this action cannot be applied anymore, or the name was taken? You know, the problem of the real applications. But again, it's not a problem, because in Redux, there is a very interesting thing. It's called time travel. In any moment, Redux can undo some action or remove one action from the whole history, because it's how Redux works. because it was created for hot reload. This is the reason. And we can implement the same thing. For instance, initially the name was A, and then user changed the name to B. We update interface immediately because this is optimistic UI. And in the background, we send rename to B to the server. Unfortunately, this name was already taken. And in this case, server could ask our client, like our application, to undo renaming action. And in this case, the project name or like task name will be switched back to the A. It's already implemented. You don't need to write it. This is how Redux works. OK, it was simple cases. Unfortunately, there is some distributed system is a little more complicated. It's very easy when idea is inside your mind, but it's very hard to implement it. So we have multiple clients. All these clients could create action in any moment, and then they synchronize across the system. It's really a mess. And in event sourcing, there is one big problem. If you will have a different order on different clients, it is so bad system. You will have a different final state. It's so bad that if you will find it in your product, as a developer, it's much better to you to run away. It's an unsolvable problem. The easiest way is just to burn whole system to the ground and start again. It's really insane. So we need some solution to be sure that order will be always the same. So we need somehow to sort our Redux actions on any machine and predictable. OK, we can use time. But to be honest, time is very easy when it's inside on your watches. But when it's part distributed system, it becomes much more complicated stuff. For instance, sometimes time could be equal because operations are too fast. You can do multiple operations during 1 millisecond. Or, for instance, sometimes time could go back because of synchronization, because of time synchronization process. In any moment, machine could ask a new time from the server, and then it will go, revert time to the past. My favorite part about this going back idea is leap second. Does anyone know leap second? Leap second, we have a leap year, but we have the same with second. Every year, special committee have a meetings, and they decide to add or remove 1 extra second. The second, to finally finish all tasks that you didn't finish for this year. It mostly apply on in the new year. And for instance, this case drop Cloudflare servers. Because the time went down, the whole system was dropped in the new year. Everyone is drunk, nobody can fix it, you know the problems. And third problem, unfortunately, every client have unique time without connection to each other. It's really insane to do something with real time. So time is not an option. We need some different time. So let's go back to the dungeons of distributed system. And there we will find a very interesting idea. If we will remove the time, we will remove the problem. This idea from Lamport clock or logical clocks. Idea is very simple, to be honest. We have a counter, just a number. And every time when we need new time, we increase this counter and add unique client ID. And third important part, when we synchronize action across the machines should take the biggest time from all the actions which was synchronized. In this case, first client A create a new action with time 1, then it send it to the second machine, and second machine increase its own counter because it's received counter number 1. Create new time, but if they create, they could create time in the same moment. This is why we need to add unique client ID to have a unique time. OK, we solved this problem. Let's go to a more harder problem. As I showed to you in event sourcing part, we can fix the problem with conflicts because we operate with actions, not with the whole state. But it was a very simple case. Maybe someone already wanted to ask a question. But what if users change the same field? How we can deal with this? Or for instance, how we can implement collaborative text editing. It's really hard. So, to be honest, it's a completely different question. It's a question what we must to put inside our actions, how we can make our actions atomic. If we will make our action atomic, we will fix the problem. But this is a big problem, how to make it atomic. So, go back to the dungeons of distributed system, and we will find a very nice idea called CRDT. It's a pretty young idea. I think it's illegal to sell alcohol to it. It was created by 4 scientists. I put their images for very important reasons. I had this talk in Porto, and after the talk, one guy came to me and I started asking very hard questions, and I have no idea why he started to ask this hard question. This was because he was a creator of CRDT. But he liked the talk. So, CRDT, it's conflict-free replica data types. It's a list of the data types. Each data types could be very different. Some types is operation-based, some is state-based. Some use distributed timer, some don't use it. But every type have a limit, and every type have a list of operation which could be applied to this structure. And each type have a rule that every client could create the action independently without one server, without asking anything, no master. But when they will synchronize the state, when they synchronize the list of the action, they all will have the same state. So for instance, these 2 clients create action to rename the project, but that client was later. And this is why he overrides the changes of previous one. So, if we will open CRDT types, we will find a lot of solutions. Like to make likes atomic, we should not set likes to some number. We should use increase and decrease operation. Okay, it's easy. But how we can deal with the text? First idea, we can have action which will tell to change each symbol. If user change one symbol, we will have a special action, remove symbol at position 1. Looks like good idea. Unfortunately, not in the real. The main problem is that if we remove some symbols or add, we change index of other symbols. For instance, if client remove C and different client put H after this index 1, after merging all this operation, we will have completely mess because the whole indexes become different. So we need some solution. And if we will open CRDT, we will find a very good solution called persistent indexes. What if we will not change index of each symbol every time we change something? So when first client remove C, the symbol in position 1 or 0, depends on your programming language. I started from Pascal, this slide first. And second, if he or she removes the symbol number 1, different symbols don't change index. And if we insert symbol between 1 and 2, we will use number between 1.5. In this case, we will have a persistent index, and whole system will work. But unfortunately, CRDT could not fit any real application. This is a very good idea, but it's not silver bullet. This is why you should use it as an operation. To create atomic actions depends on your system, depends on your business logic. So, what did we create? We created to-do manager, which could be work collaborative. Fine. We created by using Redux, Vux, or any other pure function, state manager. We put a distributed time to each action. We synchronize the Redux action by the WebSocket. We remove all AJAX requests, just WebSocket, just synchronizing. And we use time travel to apply action from the past, which was created different user in the past and then synchronize it to us. And we use CRDT to make our actions atomic. Yeah, we solved the problem with to-do manager, but maybe we created something different. Like maybe we create a system which could be applied to multiple times. So for instance, one case. If one user will be click on the checkbox and then unclick it, in the classic system, we will send 2 AJAX requests. But unfortunately, in the real, this request could be received by the server in the different order. This is how network works, deal with it. And as a result, a lot of the system right now, even Facebook or something bigger, they will have a problem. They will apply the first action in the last, and they will override. It's a very popular system. Even GraphQL and Ajax everywhere. But if we will use CRDT, if each our action will have a time, server will ignore action from the past because it could change the time. It happens because Ajax request and GraphQL it's very good technology, but they created for the perfect internet, like on your machine when you're developing a program, when everything is good, when a system with performance are great. But unfortunately, real internet is a little different. And real internet is really buggy sometimes. My family lives in China. I really like to visit my family, to eat borscht of my mother. But in China, because of Chinese firewall, they drop half of the packages to any Western websites, even not block it, even legal websites. They drop just half of the packages, and it's completely insane to work. All our sites stopped working there. But it's not the problem only of China and some different countries. In New York, they don't have a stable connection in the metro, in subway. It's very lame to use a subway in this case. And to be honest, the next billion users they will definitely not have a good internet. But the whole CRDT was created to working on this environment. The whole CRDT was created to work perfectly in this case, and this is why. If we will use CRDT, we will have more clients because we can use your application in Subway because it works much better. And more clients means more profit. Second, it was created, CRDT is so good with bad connection because CRDT is completely decentralized model. It was created to work completely peer-to-peer without any servers. Of course, it's not easy to implement in the real application, but because CRDT was created to be peer-to-peer, you can apply some of the feature of CRDT to your centralized system. For instance, it makes much easier to create multi-master servers, or for instance, to synchronize action between browser tabs. So all this action could not be sent to the server. It could be also synchronized across browser tabs. If you do something in one browser tab, it could be synchronized by local storage to different browser tabs. Or you can do some completely peer-to-peer mesh system. So CRDT was created to be peer-to-peer, and this is why it has better scalability. It's always good to have. And also, CRDT is created to have optimistic UI. Unfortunately, you can't have optimistic UI without good conflict resolution, because optimistic UI means that you are not sure, do you have internet or not? The only way to check internet is to send some package. And this is why it could be offline, and this is why you must have predictable conflict resolution if you want to make really good optimistic UI. And optimistic UI and live updates in CRDT created by design, they're not added by some hacks. And this is why it's a third good feature of CRDT is that it have live updates out of box. This is why your user will have a final state of your and have less mistakes. But also, optimistic UI means that your interface, at least user, thinks that it works faster because it applies changes immediately. And performance is really important because performance connected directly to a profit. And this is why with optimistic UI you will have more profit. There is a lot of proofs about it. And this is why CRDT right now is a trend. It's used by Atom. In Visual Studio, Redux have CRDT types. SoundCloud use CRDT now in their servers. But I'm suggesting a different idea. I'm suggesting to use CRDT not for some special cases, but to any application to make them better, to make them faster, to make them more stable with a bad connection. So this is why I believe that CRDT will be the next big thing after GraphQL. And right now there's a lot of solutions, Swarm.js, of course. But of course, I have my own solution. It's called Logux. And that's all. This is my Twitter of Evil Martians. Questions? Whew. Yeah.
Does it keep like a transaction history? So if like missing packets, right? And something goes through and it has an older timestamp than the newest one, does it do that transaction and then play all the new ones, or does it just throw the old transaction away?
It depends. It depends of what type do you use. Some CRDT types, like I'm talking about the idea. I'm talking not about the implementation. But if we will speak about Logux, in Logux on the client side, yes, it will do the transaction things. It will go roll back the whole history of your state, put your action, and then go forward. On the clients, on the server side, unfortunately, we are not able, for most of the cases, to do it because we don't have infinite memory. We can't put the whole state to the memory. This is why on the servers, it will be much better to look to database and check time. So it depends on the system. Some other questions? Okay, so if you will have some question, ask me after the talk. So thank you. Oh, thank you. So thank you. Yeah.